Hello all, this video is going to a continuation video of previous video only. Previously for email spam detection, we have worked with many machine learning algorithms, and in this work we are going to work with another machine learning algorithm, which is SGD classifier. So for that we are importing the library and data set we needed. The data set we have downloaded from Kaggle only. You can just give us email spam detection data set, means you will get this data set. That data set is having nearly three entries, unnamed one, email text and email type. Then we are getting the info of the data set. From that we are getting to know that the email text and type or object type, and others, that is unnamed, is integer. Then we are getting and checking whether the data set is having any null entries. Within email text it is having some 60 null entries, so we have to drop it. Along with that, you may notice that within the unnamed entry, which is the integer type, it is just an serial number, so we don't need it, so we can drop that also. So for that we are using the drop function, drop now function, and drop duplicates function, and again we are just checking the missing values. Now you may notice that we are not having any unnamed entry, and we are not also having any null entries with the email text. Then we are getting the shape of the data. It is having nearly 17,538 entries. Then we are plotting this two classes which we are having, which is safe email and phishing email. So when compared to this phishing email, safe email count is high. Then we are using the train test split function to determine the variables like xtrain, xtest, ytrain, and ytest. For that we are first determining the x variable and y variable. Within the x variable we are calling the email text column, and within the y variable we are calling the email type column. And by this use of this x variable and y variable, and the test size is 0.2, that is 20% for testing and remaining 80% for training, we are determining these variables. And then we are making use of feature extraction. Why? Because here if you notice, means our x variable is in the text type, but we have to convert it into vectors. For that we are using the tfidf vectorizer. It is applied to the xtrain and xtest variables, and then we are determining the by using this xtrain and xtest, which is done by this vectorizer only, we will be using in the further model training and evaluation. So previously we have worked with some algorithms, so I'm just skipping it since we have done previously. So with the previous algorithms which we have done, if you need some detailed explanation, means you can just move to the video for that algorithm which we have made. So for that we would have given some detailed explanation. So in this video I'm just sharing the accuracies of the algorithms which we have gained. For logistic regression we have gained nearly 96% accuracy, and for support vector mission we have gained nearly 98% accuracy. For catboost classifier we have gained nearly 97% accuracy. For passive aggressive classifier we have gained nearly 96% accuracy. For random forest we have gained nearly 97% accuracy. For naive Bayes we have gained nearly 94% accuracy. For KNN we have gained nearly 73% accuracy. For decision tree we have gained nearly 91% accuracy. For gradient boost we have gained nearly 94% accuracy. For Adaboost we have gained nearly 93% accuracy. For XGboost, previously for the XGboost, why we have made this replace and all is clearly explained. The thing is, XGboost will not take text type, so with y variable also, so we have to replace it with the numerical type. For that only we have used the replace function, and that thing only again it is vectorized by use of this sorry, this x variable is only vectorized, but this y variable it is not. It is just changed to this numerical type, then for that we are getting an accuracy of 97%. In this work we're working with XGD classifier. For that we are making the import function for that classifier, and then we are calling that classifier within a variable. That variable we are using for the fit function and predict function. Fit function is used to work with the training variables. Predict function is going to work with testing with the testing variables, and we have displayed the predictions. The predictions are displayed within an array. Then we are displaying the confusion matrix. May notice that our data set size was nearly 17,000 something size, but here if you notice means we are getting only less number of count with this confusion matrix. The reason is within the confusion matrix we are having only some 20% of data for testing, and for confusion matrix creation and all we are using only the test variables. Now not only in confusion matrix but also in classification report also we are using only the test variables for plot. So only it is showing some less number of count. Then we are displaying the classification report. For this we have got 97% accuracy. In some algorithms there will be some change, that is originally it may be 93 or 94, but in this comparison plot it is some different, because since it's a series, previously while we are working with this algorithm it showed some different accuracy, but while we are working again and again there is some little bit change, not so much, nearly one or two, not very much. So only if you are finding any changes means it is due to that only. Then we are displaying a bar plot to make the comparisons for all the algorithms which we have made so far. From that you may notice that the support vector mission is the one algorithm which is showing 98% accuracy, and this KNN is the one which is showing the least accuracy is 72. After this support vector mission, some 4 to 5 algorithms takes to place, including this SGD algorithm which we have implemented now. In the next video we will be working with the MLP classifier, and also will make a comparison with the other algorithms we have implemented so far. Thank you.